Chris Smith, the Naked Scientist, a very good morning to you, sir.
Hi, morning, Kino.
Now, I was jumping up and down there, but I mean, Paul raised a point, and I think it's a point that a lot of people possibly agree with, and maybe that's a good place for us to start.
I heard some of what Paul said. The discussion seemed to dwell around the benefit or disbenefit of putting compounds like mercury in vaccines and whether or not there may be consequences of doing that, either in a good or bad direction. Now, first of all, we should perhaps explain, well, why do people who make vaccines put compounds like thiomersal, which is one of the compounds, which is a mercury compound, into vaccines? And the answer is that because we're injecting very, very young people right through to very, very old people and infirm people with these vaccines to protect their health, were we to end up with a contaminated batch of vaccine in which microorganisms had flourished and grown, there is the possibility that you could be injecting people with something horrible that's then going to lead to them becoming extremely unwell. So the mercury is there as a suppressant to prevent the growth of microorganisms that could endanger health. So that's why it's there. It's there for good reason. So then you say, well, what consequences might there be? You have to consider everything in terms of its dose. The dose that's in these vaccines is minuscule, and therefore the potential impact on the body, even if there were an effect, we're not even at that stage of this argument yet, but let's say there were an effect, even if there were one, you'd need a dose to trigger that effect, and this dose is so tiny, and the number of vaccines that people are having is so tiny, the impact is going to be inconsequential. And then there's the question of, well, okay, if we accept that there could be an effect, what is it? And let's go looking for it. So with any kind of thing that causes another thing, a causal relationship, if one thing causes something else, there should be what we call a dose-dependent relationship. What that means is that the more of something that you are exposed to, the more of the outcome that it causes you should see. That's maths and statistics, and it's one of the ways in which we prove causation. Therefore, if we go hunting round in the population and we say, well, what's the burden of vaccination? And then we say, what is the burden of whatever disease we think might be linked to vaccination? And that relationship does not exist. It certainly doesn't exist for many of the conditions that have been cited as being caused by these vaccinations. And then you ask, well, okay, in the absence of that evidence, because an absence of evidence is not the same as proof that it doesn't do something, on the other hand, what will happen if we don't give people vaccines? And the conditions that we're vaccinating against, these vaccines cost a lot of money. And so for governments internationally to invest the scale of resources that they do, then they have to have reasonable grounds for suspecting that this is going to have a population health benefit, because otherwise they could spend the money on a whole heap of other really, really high priority things. And so the evidence is the diseases that we're preventing and the disease burden that we're preventing with these vaccine schedules actually far outweigh any theoretical risk from these other compounds. And I think you made a very pertinent point when you were talking to Paul, which is, he said, I've been watching YouTube. Now, there's some great content on YouTube. There's some really fantastic, academically sound, scientifically robust and rigorously researched content there. There's also a lot of rubbish. And unfortunately, YouTube does not curate the stuff that's reliable and sort scientific wheat from chaff. YouTube just dishes up stuff so it can make money, because YouTube is a money-making machine that force-feeds you videos so that you watch adverts as a consequence, as a byproduct. And that makes money for everybody. So that's why they do it. And therefore, there's a high likelihood you're going to encounter, alongside some pearls of wisdom, you're going to encounter a lot of disinformation. So you have to be extremely cautious about what your sources are when you're looking at content online, because it's not curated like a radio program with an editor or a newspaper with an editor who adopts standards.
Absolutely. Buying into Harry Potter theories is one thing. Trying to read the science and speak to people who know the science and then put yourself on a sound footing when you make a decision, it is so important. This proliferation of fake news comes out because there's so many platforms like Facebook and YouTube, etc. People put all sorts of nonsense out there, and there are some gullible people who go out, and I don't necessarily blame them, but they go out and they watch it, and all of a sudden that becomes their new doctrine. So my measure is always rather go to places like publichealth.org or the World Health Organization's website and go and find out more about those concerns, but go to a credible source. Now, Chris, let's move on. Let's look at this one. What is invert sugar? I watched the science program in the 80s, and it explained how it could prevent tooth decay because the in inverted commas, invert sugar molecules are a mirror image of the normal sugar molecules, and does not sit on the teeth as easily. Do you know about that?
There's an enzyme called invertase, and yeast has a lot of this. And what it does is it converts sucrose, which is a disaccharide. It's two miniature sugar molecules stuck together to make a bigger sugar molecule. And those two miniature sugar molecules are glucose and fructose. So what invertase does is it splits sucrose into those two monomers, glucose and fructose are isomers of each other. In other words, they've got the same number of atoms, but they're just arranged differently in three-dimensional space. So the same chemical formula, they're both C6H12O6, but the arrangement of the atoms in space is different, and their chemistry is slightly different. I'm not familiar with the claim that, therefore, if you do this, it will sort out your tooth decay. Any sugar that a bacterium can digest and turn into lactic acid, which is what happens in your mouth in dental plaque and is what erodes teeth, that is really bad for your teeth. So minimising your sugar intake is really good for your teeth. It's also really good for your waistline.
Right, thank you very much for that. Chris Gavin in Somerset West, thank you for being patient, sir. Go for it.
Thanks for taking my call, Kino. What I wanted to ask Chris was, I've read something about a process called aquamation, which is apparently an alternative to cremation. Perhaps you'd like to just elaborate on how this works, what the cost implications are, and if it's a good thing.
Wow, sounds like sharks eat your body while you're floating. Anyway, Chris?
Wow. Gavin, I have to admit, I've never heard of it. If you can send me a link or something, I'll take a look. But I'm really sorry you've been waiting in vain. I don't know what that is. But what I can say is that there are lots of alternatives to being dumped in the ground with a gravestone on top of you. And one of the most interesting I heard in recent years was one company said that they were offering to freeze-dry bodies. So you dump your body in liquid nitrogen, and the liquid nitrogen's at about minus 200 degrees, so it freezes you solid, and then they use high-frequency sound waves to blast you to pieces. And then you just remove the liquid nitrogen because that just evaporates off, and you're left with this sort of human shrapnel, which is a sort of dust. And you can scatter that rather like ashes from crematoria, but you wouldn't have the carbon footprint of having burned off all the diesel to do it. There is a carbon footprint there because you've got to compress that nitrogen down to make it into a liquid in the first place. But there you go. If you're looking for alternatives for normal burial and you want to do something a little bit more exciting, maybe that's something to consider.
Well, here's something. In Australia, one company recently started selling a greener alternative, Aquamation Industries. They claim to offer a unique, cheaper, more carbon-neutral method of body disposal. It says here, Aquamation employs a process called alkaline hydrolysis, in which a body is placed in a stainless steel vat containing 200 degrees Fahrenheit, which is about 93 degrees Celsius, potassium hydroxide and water solution for 4 hours until all remains is the skeleton.
Yeah, I mean, that's pretty standard. People used to dump bodies in lime pits to get rid of them when they'd done something nefarious in the past, because lime, well, I say lime, but things that are really alkaline, and potassium hydroxide is exceptionally alkaline as a substance, that will attack all the protein and the soft tissue in the body and break it apart, whereas skeleton is calcium phosphate, so that's why you get your skeleton left behind. So I hadn't come across that. I'll take a look, but it's certainly interesting. I interviewed another sort of startup company the other day, and they don't offer an alternative to doing cremations or something, but what they do is an alternative to how you scatter ashes. And they have a device where you put the person's remains in a casket, a little tiny box, and sling it under a helium balloon, and it then ascends to the edge of space, at which point a special sensor detects at what altitude it's at, opens the box and scatters you to the four winds 33 kilometres above the Earth's surface. Then the balloon pops and the whole lot comes back down. So that's another way of scattering your ashes on a global scale.
Oh, wow.
You will literally be in circulation around the planet for years to come, because it's going to take a long time before you come back down.
Well, it sounds like a cheaper alternative, getting close to space. Other people are spending hundreds of millions, and you can go up in a balloon.
Well, when you die, in theory, you go up to heaven anyway, don't you? But I'm not too sure about that.
Yeah. I'll have to look out for the YouTube video on that one. Now, are crude oils quite uniform around the world, or do they contain different proportions of petrol, gas, diesel, and paraffin, etc., is another question that's come through.
Oh, lovely question. The answer is no. Crude oils are not all made equal, and they range around the world, and some places produce different grades of crude oil. They're crude oils which are very, very heavy, And in other words, I don't just mean when you put them on the scales, they weigh a lot. When you look at the oil chemically, you see that oil is a mixture of different molecules, ranging from extremely light, small molecules like the molecules that we put into petrol and that we burn as gas, right down to very heavy, long chain molecules, big polymers, which we put on road surfaces. And when we distill crude oil, what we're doing is heating it up and separating using temperature and boiling points all these different sized molecules. And different grades of crude oil come from different geographies and therefore have probably different things going into them and different processes that have led to their creation in the first place, because the geology differs around the world where crude oil forms. Though those oil compositions will be different, and therefore the relative amounts of the things that are in those oils will be different. And as you can probably therefore anticipate, some oils will be much richer in the things that we find most useful and for which there is the greatest demand, others less so. So there's very sweet light crude, which is a sort of honey colour, right down to this really heavy-duty, thick bitumen type stuff. And the amount of energy needed to refine them to get a high yield of the things we do want relative to the things that are less useful will differ between those oils. So there are some countries that are blessed to have, if you can call it blessed in this climate conscious era we're in, but they're blessed to have a certain composition of crude that their country has there, which is very, very easy to refine and yields a very large amount of the stuff we do want and less of the stuff for which there's less demand. But no, crude oils are not all made equal.
Okay, now, a WhatsApp statement or question that's popped in. I've used the equal quantity of salt and bicarbonate of soda to clean my teeth all my life. The dentist says that it stops the acid building up. Still have all my teeth at 72. That's not
brilliant.
me, by the way. It's from the listeners. Yeah.
Brilliant. Well, what's the rationale for doing this? Well, bicarb is sodium hydrogen carbonate, and it's the same stuff we put in baking powder, actually. And when we put it in baking powder, the high temperature of the oven causes the molecule of the bicarbonate, hydrogen carbonate, to decompose, and you get water and carbon dioxide coming off. And the carbon dioxide then blows up your loaf or your cake. That's why you get a fluffy sponge, because you've got bubbles of gas in the cake, and that's why we call it baking powder. But when you put it in your mouth, the bicarbonate is also a weak alkali, and it will react with acids which are produced by plaque bacteria, which are the bacteria that live in the calculus, the hard stuff that forms and furs up your teeth. And those bacteria use sugars, convert the sugars via various metabolic pathways into acidic substances, including lactic acid, and this, over a lifetime, slowly attacks the surface enamel of your teeth. So if you clean your teeth with something that's alkaline, then it will actually help to negate some of that acid effect. The other point is that toothpaste is a bit abrasive, and if you go straight to the toothbrush after you've eaten breakfast, because you've just fed all your mouth bacteria at breakfast time, then you have lowered the pH, the amount of acid that's in your mouth has gone up, and this means your teeth are being attacked a bit by mouth acid. So if you chuck something alkaline in your mouth, I wouldn't advise swallowing it because you'll neutralise your stomach acid, but if you rinse your mouth with something a bit alkaline, like bicarbonate, you can reduce that effect, and therefore you can reduce the erosive effects on your enamel. And then when you scrub the toothbrush around, you haven't got such soft enamel which will be more easily damaged by the other abrasives in the toothpaste. So there's a sound idea to doing that. Be careful with the salt though, because salt, if you swallow too much salt, this is not good because it puts up your blood pressure.
Now, I'm not sure whether we dealt with this one before. My gut tells me we did, but let me ask it nonetheless. We keep hearing mixed views on whether sort of crackling of knuckles and other joints are bad for you. Arthritis, swollen knuckles in later life. But is it bad for you?
Probably not. Phil, who works with us at The Naked Scientist, sits in the office and cracks his fingers pathologically, and it drives me mad. I hope he's not listening to this programme, but he knows it drives everyone mad because he's stopped doing it so much lately, because I think he's seen everyone kind of jerk convulsively every time he does it. But first of all, why is this happening? It's happening because when you apply force on your joint, you drop the pressure in the joint space, and in the joint space you've got the end of one bone covered in a layer of cartilage, the end of the other bone it's going to rub against covered in cartilage, and between them is a liquid called synovial fluid. When you pull the two bone ends apart, you drop the pressure in the joint, lowering the pressure in the synovial fluid, and this encourages the formation of a bubble. So a bubble pops into existence because of the low pressure there. There's also one guy called Daniel Unger, who is a German chap, and for some reason best known to him, he cracked the fingers of one hand all of his life, but not the other hand. So you therefore have got a controlled experiment with one person who's cracked the knuckles of one hand, but not the knuckles of the other hand for 50 years. He didn't have more arthritis in the cracked hand than the uncracked hand. He did, however, have a little bit of weakness in the hand that was not cracked, but that could have been because he was the opposite-handedness. I don't know the ins and outs of that one, but his name was Daniel Unger, if you want to look him up.
I can see some people going, crack your knuckles, get stronger hands. Maybe not. Let's go to Matt. Matt's in Frederhoek. Hi, Matt. Good morning.
Hey, Kino. I just I've always wondered what the relation, or how different something very acidic and something very alkaline is in terms of what it can do in terms to like soft tissue and I suppose the metals and everything. Like, how different are they when they react?
Chris?
Hello, Matt. Well, when we talk about how acid or alkaline something is, we're referring to its pH. And the pH scale goes from 0 to 14. 7 sits in the middle, and that's water. And what this scale actually means is the amount of hydrogen ions which are in the solution. Hydrogen ions, H plus ions, are the component that is an acid. Basically, it's a proton. And when we have something which is very low down the pH scale, at pH 1, for example, that's stomach acid or battery acid. And that means there's enormous numbers of these hydrogen ions there, and they can attack things that want to react with them. At the opposite end of the scale, you have a very, very much a solution dominated by hydroxide, OH minus ions. And they're very good at absorbing hydrogen ions. So in other words, they're the sort of mirror image of an acid. They also, though, are chemically very active because some things will be attacked very, very much so by an alkaline solution. And I mentioned one of them earlier. Proteins in your body are very susceptible to being denatured and destroyed by alkali. But so acids are very good at doing that too. And so it will depend on what the chemical reaction is that you're investigating. Acids will be very good at breaking bonds between things where you want to add one of those hydrogen ions to something. So if you took, say, a sugar molecule, you can add an acid to it and you can break apart the bond between the sugar molecules by saturating them with water, where acid helps to break that bond and then insert some water between the two. So that's one example. At the opposite end of the scale, alkalis can be used to attack anything from soft tissue through to aluminium. You can actually erode the surface of aluminium and make it nice and bright and shiny if you put aluminium in sodium hydroxide, for example. So it's chemical horses for chemical courses. It will differ on what sorts of reaction you're investigating and what you want to achieve.
Well, Chris, thank you very much for that. Thank you for your time, sir, and have a wonderful weekend.
Likewise, Kino. Thanks, everyone, and until the next time, bye-bye.
Bye-bye. There we go. Dr. Chris Smith, the Naked Scientist.